Alright, man. Hey. I've been reading about the laws of thermodynamics. I won't go into the equations, just basically the fundamental principles abstractly, if you like, in a generic way, in layman terms. Yeah, just basically so that everybody can understand um, what these laws mean. Now, the laws of thermodynamics were invented by men, really, to explain the way energy transitions from one state to another in nature. Energy that basically, that's just packets of energy like quanta um, to waves of energy, if you like, which is a collection of quanta that form that wave function, if you like. So anyway, thermodynamics is a way of explaining hot and cold. Yeah, right. So and there's one funny law of thermodynamics. I've always found it funny. Entropy and the arrow of time. Yeah, so human beings were funny, man. So anyway, roughly speaking, it goes like this. Well, entropy and the arrow of time, right? So things become less ordered as time flows, right? So if you have a system that has, let's say there's a building there, right? As time goes, that building degrades and eventually becomes run down and it loses its form and it becomes more chaotic rather than structured as time moves forward. Now, that's the law of nature. We think, yeah. So, if things become less ordered as time flows into the future, then how do you explain coming from a chaotic Big Bang to an ordered solar system and galactic system, right? It appears as if things are becoming ordered as time goes into what we think is the future. So what I postulate here is that we're actually going backwards in time. Yeah, we're not actually going forward into the future, because the law of entropy, yeah, tells us that things become less ordered, not more ordered, as we flow into the future. So if things are becoming more ordered, that suggests that we're going backwards in time. That's why it suggests. Obviously, I haven't set up any experiments to prove this, yeah. So it's just like a concept I've just come up with, and obviously this is a talk on the Mandela effect. So where you start to see discrepancies in the flow of time, yeah. And now one way of knowing which way time's flowing is to look at order and disorder in the universe. If the universe is bounded, yeah, then we should be seeing it becoming more chaotic, not ordered. But it appears to have been becoming more ordered from the Big Bang, right? So, looking at the universe from the Big Bang, you have to say that it's going backward in time, not forward, if the law of entropy is to be followed, unless it kind of like interacts with something else beyond its boundary. Unless it makes another system beyond its boundary more disordered, yeah, which is what the law of entropy allows for. But if the universe is just one universe and it's got a boundary and there's nothing beyond it, then if it's becoming more ordered, it means that it's going backward. We're going backward in time, yeah. We're going backward in time rather than forward. So I started thinking about entropy and time traveling. I was thinking, how would we know if we're going backwards or forwards in time? Like, think about it. If you have a memory, yeah, of yesterday, yeah, that's today minus one, day minus one, right? And this is followed by a memory of the day before that, which is today minus two. And this is followed by a memory of a day before that day, which is today minus three, yeah? And then this is followed by a memory of the day before that one, right? So you have yesterday's memory, day minus two, day minus three, day minus four, and this is what's happening as you go forward in time. Your mind will be pretty comfortable with this. So let's say I'm sitting here and then I start to remember, oh, yesterday I took the bus. Oh, the day before that I went to the shop. Oh, the day before that I met this girl. Oh, so I'm actually going back in time, but in my reality, the next event is a previous day to the current event. So my mind is quite happy going backwards and forwards without. I will always think I'm going forwards. Yeah, like if the Earth is going around the Sun in one direction, yeah, we'll see the same thing as if it was going the other way around the Sun. We wouldn't notice any difference. When it goes the other way, it doesn't mean that it's going back in time now, does it? It just means that it's going the other way in time. We won't really know, yeah, whether it's forward motion or reverse motion. Yeah, we'll just be going around the Sun. That's all we will see. Yeah, around the barometer. Right. So my take on this is that time travel might be something that we can't consciously understand, because if we were to go back in time, which I believe we're actually doing right now, we have no way of knowing that. we're okay. We can look at entropy, yeah, and say, hang on a minute, why are things becoming more ordered? Yeah, should they be becoming more disordered? Is it? So it's like having me splash liquid all over my carpet, and then the next thing I see is it becoming unsplashed. I'm coming back to an order. It's like, and I'm looking at that. If I'm looking at that, then that's how I know that nature's going back in time. But I know what scientists are gonna say. They're gonna say there's something beyond the universe, so it's making something else beyond it more disordered. That's why it's becoming more ordered. But then that will touch into what consciousness does when it looks at nature. Yeah, because when we look at nature, like if you look at the double slit experiment, if we look at a natural process like that, it stops being disordered and becomes more ordered just by us looking at it. But in my mind, in our minds, we get headache. We're like, how? When I'm not looking at it, it looks disordered, but when I'm looking at it, it becomes ordered. So, but then that's a transition. That's like it's going back in time. But to explain what going back in time is, when you're the subject matter that's actually going back in time, it's not an easy thing, you know. So I just want to leave you with that. If we are actually going back in time, then how could we possibly know that?